Good evening, students. Today let's start with a new chapter. It is laws of motion. So under this, mostly we'll be dealing with types of forces. Okay. So first we'll know what is normal force. Because laws means all the Newton's laws will come into action. What is first law of motion, second law, and all that. But before knowing that, I think it's better we should understand how forces act upon any body and all. So basically, what makes a force do? Whenever you apply a force, it's like some kind of quantity or some kind of unit. When applied on a body, it changes the state of the body. Suppose if it is at rest, if you are applying force, consider a ball itself. If you have a ball, you are just applying some force, it will start moving. Or if a ball is already moving, okay, then you apply some force in the opposite direction, okay, then what will happen? It will come to rest. So basically, anything you want to change the state from rest to the motion or from the motion to the rest, you need some kind of force to stop it. Not necessary you have to go and touch it. Sometimes it could be like any ball. If you just roll it, you must have noticed it will not keep on rolling forever. After some point, it will come to some stop. Why? Because of the ground. The ground is not exactly smooth. So because of some frictional force, there will be small stones or some grass or something. Because of that, it's like the small these are trying to resist the motion. So automatically at some point the speed will reduce, and then it will stop. So force is nothing but some kind of quantity which will always change the state of the body. So we know that its unit is always newtons in SI system or the standard international system, and always represented as dynes in CGI system. You know that force is always a vector quantity. Because it has magnitude as well as direction. Because definitely it depends on which side you're applying the force. Because if a ball is moving in this direction and then you want to stop the ball, again if you're applying the same direction force, it will move even faster. So it depends on which direction you put. That's why it's called as a vector quantity. Always how much force you are applying and in which direction also you're applying matters. So there are various types of forces. The first one is non-contact forces. Second one would be contact force. Third one would be a weak force. And the fourth one is called as a nuclear force. We don't have these two. What we'll be studying is non-contact force and the contact force. In general, there are various types of forces, that weak force, nuclear force and all, not required for us. What we need to know is what is a non-contact force and a contact force. we'll see what is the non-contact force. Without even having a contact with the body, that kind of force has some impact on it. It can still make the body change its motion. Okay, so that non-contact forces in day-to-day life, we always see this force. Gravitational force, contact. Any ball is there in the air, you are not applying any force on it. Suppose if you are just leaving the ball in the air, like you are standing on a tower and you just leave without even applying any force, still the ball will come down because there's always a gravitational force. It's not even coming and trying to contact, coming and hitting on the body, but still it makes an impact. Okay, so without even having a contact, gravitational force. Second is magnetic force. Third one is electrostatic. These two will be studying in 12th standard in detail. Right now what we have is only gravitational force. Magnetic force also, if you have some iron, okay, any iron rod, any iron metallic thing, and if you keep a magnet without even contacting, you can still make this iron part move towards it. Why? Because of the magnetic force or the magnetic field which the magnet creates. So that's why it is called non-contact. Even without touching it, you can change the state of the body. Same way, electrostatic also, whenever you apply current across any conductor, no, it creates some electric field similar to magnetic field, under which if you put any object and all, it will change its state. So these two anyways not needed in detail. This anyways will be studied. Gravitational force. Contact forces. Various types of contact forces. First one is called as a tension. Second one is called as normal force or a reaction. Third one, spring force. Fourth one is frictional force. This I'll explain to you in detail later on, but just to know what the different types of contact forces. Before going in details, I just want to tell you what is the difference between a balanced force and unbalanced. Because under laws of motion, no, you'll come across this word many times, an unbalanced force or a balanced force acting upon it. Just giving you an example. Suppose if you are playing a tug of war, there's a rope. Okay, there are two teams. Now there are people pulling the rope. Okay, so there will be a rope which will be getting pulled off on both the sides, A and B. Now what this side team is doing, team B is trying to pull the rope on this side. We will consider this as F1, the other side is F. Now if this one is also applying exactly 10 Newton, suppose, and this one is also applying exactly 10 Newton. So what is going to happen? This rope will not move in either of the side. Why? Because we are exactly applying this side also 10 Newton, this side also 10 Newton. So the force is getting balanced both the sides. Both the team are applying equal force, but remember that they are in opposite direction. Imagine they also start applying in this direction only, all will reach this side. Okay, so a very important thing is for balanced force, equal in magnitude, but opposite direction. Acting on the same body. Now the body is what? The rope. Net force is equal to 0. Why? Because this is like F1 and this is in the opposite direction, minus F2. So 10 minus 10 will give me 0. It's like no applying force only. Even though they are applying force, but how it looks like they are not applying any force because they are cancelling out each other, the forces. So that's called as a balanced force. So whenever you have a balanced force acting on any body, it's like equivalent of no force only acting on that body. So the net force over here is 0. And this will always make no changes rate of move of the object. No change of state of the object. Basically does not move. The object will not move. But whereas for unbalanced force, what is going to happen? Suppose for the same team, if this side there is 15 Newton and this side there is 10 Newton. Definitely now this is an unbalanced force. Team B will win. Here what is going to happen? There is no movement. Okay, here we have anyways written, so the rope will not change here. No one is winning still. Here definitely the team B will win because they are applying a greater force, so this rope will get pulled in this direction. So this is called as an unbalanced force. Okay, this is exactly opposite, not equal in magnitude. Over here, even if direction are in opposite or in the same direction, it will not matter. Okay, any direction. Imagine if both forces are acting on this side only, they are still unbalanced forces. They are not balancing each other. They are like getting added to each other. Doesn't matter in any direction, but they are not equal. Net force is not equals to 0. Either it will be some positive value or it will be some negative value. Causes the object to move or change its state. State means what? Either from rest to the moving state or from the moving state to the rest. So this is the difference between a balanced force and an unbalanced force. Here what will happen? Neither team A nor team B will win because nobody is moving on each of the sides. Any doubt with this? You can ask. No. The gravitational, I just quickly just one word I'll explain to you what it means and then in detail later on. The gravitational force, if you have any two objects, so object 1 and object 2, between them there will always be some gravitational force. Between any two bodies there will be always some gravitational force. This has mass 1 and this has mass 2. Then the gravitational force is given by this formula, G times m1 m2 upon r square. R is nothing but the distance between, and this G is called as a gravitational constant. Now don't get confused with this G. Capital G means always gravitational constant, small g means always acceleration due to gravity. This fellow is at 9.8 or 10 meter per second. And this gravitational constant is different. So remember, there's always some gravitational force between any two objects. So this was the non-contact force, you can say. Now we'll see the contact forces, that is tension, what tension actually means. Now if you have your ceiling wall, okay, and there's a fan. Consider a fan, okay, which is attached to your wall, to your ceiling. This fan will not fall. As per the gravitational law, this what we say, any object in space will always come down to earth, okay, because the gravity tries to pull it. So as per that logic, the fan also should fall down. But now what makes this fan, okay, remain here only at rest? So fan remains at rest. It's not moving, not falling down every time. Why is it so? As per normal logic, we think that, oh, this is attached to the ceiling with some concrete or with some clip. But that's not the logic as per the physics in terms of forces. Okay, there is definitely gravity acting upon it. the earth will definitely try to pull it down. So that force which is acted by the gravity is always given by weight. Weight is always nothing but mass into gravity. Remember, I told you mass is different and weight is different. So whenever you say I am weighing 40 kgs, it's a mass, not your weight. When a person is 40 kgs, it's his mass. Weight would be actually 40 into 9.8 or 40 into 10. That is 400 approximately newtons. So weight is nothing but mass into gravity. So this mg will always be acting downwards. Remember that. So this force, gravity is trying to pull it down. How much more the weight, more will be the force applied to pull it down. This W is for weight. Now, why is it not still coming down? Because there's an opposite force which is trying to pull it up. And that opposite force is called as tension, denoted by letter T. So whenever any object is hanging, no, or is tied to any string, this is called as like a string. Now for the fan, that pipe is like a string. STRNG. So when any object is attached to a string, there's always a force which is acting upon it against the gravity, that is called as a tension. So that tension is always equals to m. It's balancing it out. That's why the fan is not falling. If tension is less and this weight is more, definitely the fan will fall. It's like if you are tied, imagine you try to tie the fan with a thread, definitely it will fall because it will not be able to handle the weight of the fan. Why we say we cannot handle the weight of the fan? The tension of the thread will be lesser compared to your weight which is pulling it down. So you have to make sure this tension is always equals to your, otherwise the fan will fall. So this is tension, nothing but a opposite force acting against your weight. So this is always a balanced force. That is why it remains at rest. If this fan is this tension is more, then the fan will start moving upwards. Normal or the reaction force. We have a table, suppose, and you keep some object on it. Okay. Will the object fall on the ground? If you are just keeping a book on a table, will it go to the ground automatically? Any book kept on the table, will it fall down directly?
No, teacher.
No. Even if you see, don't think that why, irrespective if it's not falling also, there is always a force which is acting. This force will always be there. But now still why it is not falling? Now there is no string also. There is no string to hold it on the ceiling. Okay. For the ceiling fan and all we had seen, that was something was there in the opposite direction to hold it. But now what is happening is the table is acting a opposite force. It is not making it break the this and fall it. Otherwise, what will happen? There will be a hole made in the table and this fellow will fall out. But now it is not falling. Why? It's still on the table forever until and unless you apply some force, because there's an opposite force which acts. So that is always called as the normal force. So it's always normal means perpendicular force. That's called as a normal force which is acting in the opposite direction, and it will be equal. Normal force will be equal to this. That is why it is not falling. So normal force is always opposite to force of gravity, or also called as perpendicular to the this other side. So it is a balanced force. The moment what will happen? Imagine if you keep a very large stone on a very thin plank of table. What will happen? If the it's like a paper table, suppose. Okay, this is made out of simple paper or a cardboard. And if you keep very hard some heavy material, what will happen? The force which the paper is applying on this will be smaller compared to the weight which the gravity is applying on it. Okay, in that case, if very high weight, like large weight is kept, then it will break the table and it will fall down, because this power this will be more than your normal opposite force which the table is applying. So this is how the real life this works. Anything what breaks is because the other force is more than the opposite balancing force. In this case, it will be unbalanced. Whenever there is unbalanced force, there will be movement. So it will fall and break. Here, this will always remain at rest forever. Until and unless you don't push it, you don't pull it. After some days also, it would still remain there. In, only when it will move, some wind is blowing or some very strong, some breeze, some external force makes it move. Otherwise, it will always remain there. So, what does it say now? With the if until and unless there are some balanced forces, no unbalanced force is acting on it, the object will always remain at rest only. So based on that, it's the first law of Newton which we have to know. Newton's first law of motion. Newton's first law of motion states that every body continues to be in the state of rest or of uniform motion in a straight line unless it is acted upon by an external unbalanced force. Third law everybody knows. Every action has an opposite reaction. This also we have to know. It states that every body, okay, any body whichever is there, it always to be in the state of whichever state it is. Either it's in rest, then it will remain forever in rest position only. Or if it's moving, no, it would always forever keep moving until and unless it is acted upon by some external unbalanced force. Huh? You can't say balance, because even if you say external force, it has to be depending. If you're applying, see, the body is here and you both the sides equal force is moving, this applied, still it will not move. It will remain at rest only until and unless some unbalanced force is there. You have to specify this word unbalanced. Only when one force this disbalances the other one, is more than the other one, then only the ball would move. For example, suppose the chair on the floor will continue to remain at rest unless we displace it. Displace meaning move it, remove from one place to another. Your sofa or whatever, table, chair will remain there only until and unless you try to apply some force, try to push it. So this is Newton's first law of motion. This remains in the state of rest. Now this second example, a rolling ball on the floor comes to rest only when we try to stop it, or some external force stops it, unbalanced force stops it. Now imagine, now if this on the football ground, it was following suppose proper Newton's first law of motion, and the ball would keep on rolling forever. Okay, it will never stop if it's moving, no, with a constant speed and velocity. We'll see that later. What is the condition? If it's moving with uniform, like without any change, it would, as per this Newton's first law of motion, a ball would forever keep moving until and unless you try to push it or stop it. But now why exactly it stops in real life also after a certain time is because, not because you are going and running after it and trying to stop. Sometimes even if you don't try to stop, it will stop at some point. Why? Because it will be like what? The floor will not be like straight. Sometimes it might be like this. So what is going to happen? The ball is moving through this. So these are like friction or some external force which is trying to resist it or stop it. But imagine, as per the law, if the surface is very smooth, without any dust, without any stones, without any grass, nothing, then as per the law, it would continue forever. That ball would keep on moving. But because of some external conditions like frictional force or some stones or some wind, okay, wind is also some kind of force which applies on it and tries to stop it. Because of that, it will stop at some point. Otherwise, it would move forever. So this is Newton's first law of motion. If anybody has not understood it, you can ask. Next, what is called as inertia. That same logic. Newton's first law of, is based on law of inertia only. Newton's first law of motion is called law of inertia. What exactly it means is the tendency of a body to maintain its state of rest or state of uniform motion in a straight line is called inertia. This unbalanced force I explained to you. What does this uniform motion they keep on saying every time? Uniform motion means nothing but like constant velocity. Now consider this body is at rest. At rest, what is happening? Why is the body is remaining at rest? Because force acting on body is what? Zero. Why the body is not moving? Why is it at rest? Because the force acting on that body is zero. Or even if there are two balance forces acting on it, I told you the net force will always remain zero. So overall, the net force acting on the body is zero, you can see. Total force. Even if many forces are applying on the opposite direction of equal magnitude, still it will remain at rest. Now force means what? Force formula is mass into acceleration. Nothing but mass into acceleration. Now force is zero. When will force become zero? If I want to make force as zero, okay, when will it become zero? When can force be made zero? Mass, can I make the body's mass zero? No, definitely not. Okay, for force to be zero, definitely this part, acceleration has to be zero. Then only I'll get force answer is zero. Mass, obviously I cannot make it zero. Then the body will not exist only if I make mass as zero. So for force to be zero, acceleration has to be zero. So at rest, remember that force is zero. It means acceleration has to be zero. When you can get acceleration as zero, means what does acceleration mean? Your speed, your bike speed is increasing or decreasing. It means you're accelerating. But when I say you are not accelerating your bike, means you are keeping your bike speed same throughout your journey. Same means uniform. So when you can get acceleration in as zero, when velocity is constant or uniform. So that is what they mean. Uniform motion means it should have a constant velocity. That is the time there is no acceleration, there is no this. What is that? Deacceleration or no retardation. So that's why the body will never stop because it will continue with the constant velocity forever. But if the velocity is changing, that means you are accelerating. So either the ball speed will increase or the ball speed will decrease and then come to rest. The state of the ball will change if the acceleration is changed. So very important to know is for any inertia of Newton's first law of motion, the force has to be zero, the acceleration has to be zero. And when it is zero, when uniform or constant velocity is then applied on. or the object should be moving with constant velocity. Now many day-to-day applications are there. So this type questions can be asked, reasoning questions. Applications of law of inertia. We can consider it to be examples also in daily life. First one, when a horse starts running, the rider falls backwards. Give reason, sometimes they ask. So why does it happen? Whenever a horse, now the rider is sitting on the horse. So just when tells the horse to start running, the moment the horse starts running, no, the rider slightly falls backwards. Okay, not flying out backwards, normal. On while sitting only, the body tends to go behind. Even in the same case, if you are sitting in a bus, the moment the bus starts, slightly will get a jerk behind, not in front. Why? It is because suppose if there's a horse, there's a person. Okay. Now, if it is moving, suppose this side, consider this horse starts moving this side. So after some time, what will happen? This fellow will reach in front. The horse will reach in front. Now the lower part of the body, what happens? This fellow is at rest. This is also at rest. The horse is also at rest, or consider even the bus. Same example works for a bus. Now the bus is also at rest, and this fellow also. Now he starts moving. What is moving? The person is not moving. The bus starts moving or the horse starts moving. So the bus reaches in front. But what happens? This fellow tries to remain at rest as per the law of inertia. The body tries to remain at rest as long as there is no force applied. Now what is happening? The body is trying to take the body along with him. Okay, the bus is trying to take the person along. So the legs will go along with the bus, and the body tries to remain there only, like this. Okay, the upper part of the body tries to remain at rest. But since this legs are in contact with the bus, because of the force, it will go in front. And the person tries to remain behind there where he was initially. He tries to remain at rest only. And this fellow is moving. So that's why you tend to fall behind. Because he tries to hold this position. But his legs are gone in front because the bus is taking or the horse is taking. So the reason is now what you have to give is this is because the lower part of the rider, which is in contact with the horse, comes into motion, whereas what happens, the upper part tries to remain at rest only. Upper part of the body tends to remain at rest due to inertia. This is the answer. With the help of diagram also I have shown you what happens. Only the part which is in contact with the horse will start moving with the horse. But your body tries to remain wherever he was. But then that force, like horse will pull you so much, then it will take your upper body also along with it. But for just for that second when it starts, You try to oppose his motion. That's why you try to go backward, and then the horse starts moving in front. Same way, and write this first. When a horse running fast suddenly stops, comma, the rider is thrown forward. Now this was when the body was at rest and then the horse started moving. Now the second case is when the horse is running very fast and suddenly he stops. So what happens is there are chances that the rider will fall in front, not behind. When it's from motion, from rest, when it goes to motion, it tries to fall behind. But now here, what will happen? The rider is thrown forward. Why is it so? Because now the horse and the rider both are in motion. At a very high speed. So they all move, both are moving forward. So as per the inertia, law of inertia, what it says, this both fellows will be in motion till forever, until and unless some external force is applied on it, they continue to remain in motion forever. Now, this fellow disobeys the rule, means what? He stops, the horse stops. But what will happen? This fellow will try to move forward. Okay, he will try to run in front only. As per the inertia, he will try to move. But now his body is in contact with whom? With the horse. So what is happening? The stops means it's like he will remain behind, and this fellow is trying to move in front. So this fellow will come at rest, and then it will look like this. His upper body will, and then he will remain here. This is in contact with the horse, so that will be at rest. But this fellow will try to move. So that's why the rider will fall in front. So this is like opposite direction it becomes. So the horse is stopped, he is gone behind, and this fellow is trying to move. If you are not understanding or not, please ask. Huh? So the answer now here is this is because the lower part of the rider, which is in contact with the horse, comes in the rest, while the upper part of the body or upper part of the rider continues to move, because he wants to follow the law of inertia. He wants to keep moving. But now the horse stops, so he's trying to pull it behind. Continues to, tends to move, we can say, or continues to move, no problem. Tends to keep moving due to law of inertia. This you can write in your own words. Huh? like no proper definition as such. You have to write exactly that. Law of motion, you have to just write as it is. But this explanation you can explain in your own words. The upper part of the ride it tends to keep moving due to inertia. Same thing applies for bus also. No need to write again. Question, suppose if it is asked, a person sitting on a bus will suddenly fall in front if the bus stops or bus applies the brake. So instead of horse here, it will be bus. Or even a train sometimes they will use. More examples. Coin falls into a tumbler when the card is given a sudden jerk. Give reason. So it's like a tumbler or a cup is there, and there's a card kept on that, and there's a coin. Then you're giving a jerk to that. Suppose you're just flipping that card like this. Okay, imagine you flip the card, just give an external force. Why does this fellow is at rest? The card is also at rest. What will happen? The card will move. Actually, as per the logic, it should have gone no along with the card. But what happens? Quick, fast one if you give, the coin tries to remain at his position only. So what will happen? The card will go and he will remain there only, the coin. So that's why the card goes out and the coin falls down. You don't have to explain using diagrams, huh? Just for your understanding. So this is because the coin on the card remains at rest. Card moves. The coin tends to remain at rest and the card moves. So it will fall in the tumbler. Another question can be asked is, when we shake the branch of the tree, if it has fruits, if you have gone to remove mangoes, cashews, you will know. When we shake the branch of a tree, its fruits and sometimes dry leaves fall down. Why does this happen? Why is because whenever you try to shake the branch, no, along with the branch, what will happen? The leaves also and the fruits also are moving along with the branch because they are attached to the branch. But then what happens? Suddenly after shaking, you stop the branch. So when you stop shaking the branch will come to rest. But what will happen? The leaves will tend to keep moving. Even the fruits will keep moving. So what will happen? They will get detached or they will get separated from the branch then, because you have stopped the branch, but the leaves will continue move. Or the other way around also. You can say the moment you start moving the branch, what is going to happen is, if there's a branch, there are leaves. Now this branch you are trying to, this is also at rest, this is also at rest, the branch is also at rest. You are trying to move the branch. The branch will try to move. But what is going to happen? This leaf will try to remain there only at rest. The branch will go and keeping the leaf as it is wherever it was. So that's how the leaf will fall. Whenever you shake the branch, this is because shaking of the branch makes the branch move. But leaves and fruit tend to move, tend to remain at rest. Due to inertia. And thus gets detached from the branch. Next, you should be able to write this, huh? Giving all from whichever has been asked, like from the question papers and all, so that you all know whenever it comes, you should be able to answer this. Don't know it to by heart, it's just pure logic. Next one, dust is removed from a hanging carpet by beating it with a stick. So you must have seen. You want to remove some dust from the sofa or from some carpet. Okay, you tend to beat it with either the broom or the stick. Then all the dust starts coming out. So why does it happen? So what is going to happen? Under this mat, the dust is at rest. Dust is also at rest and the carpet is also at rest. But then when you start beating it with the stick, okay, what will happen? The carpet will start moving forward or going backward. Okay, the carpet will start moving. If you're beating it with a stick, it will move. The carpet will move, but the particles will remain there only. The particles will remain at rest. The dust particles, but the carpet will move. That's how they get separated from the carpet. So you can write same thing. This is because beating the carpet, write in your own words. This is because beating the carpet with a stick will make the carpet move. But the dust will tend to remain at rest due to inertia and thus get detached from the carpet or thus get separated from the carpet. If you don't want to use the word detached, you can use the simpler word separated. This is because beating the carpet with a stick makes the carpet move, but the dust particles will tend to remain at rest due to inertia. Next one, an athlete runs for a certain distance before taking a long jump. Because if he wants to take a long jump, why do we have to run? Why we don't start at the same point and then jump? Is there, he wants to jump, suppose. This is the starting point and then you have to calculate. If he jumps from here only, he might fall to a lower place. But if he starts running from here and then jump, he will cover a higher, longer distance. Why is it so? If you just start and jump, you will always have a shorter distance. But if you start running, you can cover more distance. This is the reason, that is law of inertia. So you can directly write what will happen when you start running, no? From far away, already your body remains in motion. So whenever you're jumping, so it's like that is like adding to it. Your body continues to remain in motion. So it adds to your muscular power. So this is because the inertia of motion gained by the athlete during the time of running and then jumping adds to the muscular efforts. Whatever efforts he is putting, this is like a plus point which has already gained while running and help him in taking a longer jump. And last one I'll give. Like this type only, they will just change the situation. You have to understand and then write. You just have to think what change of motion it is going from rest to movement or from motion to the rest. So it's always in the opposite direction of the movement. The bus is moving this side and you are there. If it stops, that means you fall in front. But if you are at rest, if the bus is moving in front, that means you fall behind. It's always in the opposite direction. Next one, a person getting out of the moving train getting out of the moving train or these are not at rest, not after the bus is stopped. Just if the bus is moving and you try to jump out of the bus, you will definitely fall. You will fall in the forward direction. Why? Suppose if this is a bus, it's moving forward. Okay. Now if it jumps, the person reached on the ground. Now what was happening? Over here also, the person was moving forward. Now the bus, he jumped. So his upper body continues to keep moving as per how he was moving in the bus. But at the ground, what will happen? At the ground, his legs will come to rest. It will touch the ground, no? So it will come to rest. But as per the motion of the bus was moving forward. So the person also continues to move forward. So his upper body will move forward, and then his ground will be, his legs will be stuck at the ground. So what will happen? He will bend and then fall. So whenever you try to jump, no, from any height or from a table, so some can balance it enough if the movement is not too much. If the table itself was moving already in the front, and then you try to jump it, then definitely will fall, because your body already continues to move forward, but your legs come at rest, and then that's why you bend and then fall. So the reason you can write it, this is because as the man jumps, these are all understanding problems. You cannot simply by heart all the applications and go. His feet or his legs, whatever, suddenly comes to rest on the ground. On the moment it touches the ground. You can mention this. The moment it touches the ground, his feet will come to rest, but his body will keep moving. Body will keep moving doesn't mean some 10 kilometers, huh? Just for that second. 1 second also if it moves, still it will fall. While upper body continues to move forward due to inertia. You have to mention the word inertia. In case in the previous examples, if I have not mentioned the word inertia, I just mentioned due to inertia. So like this type applications can be asked, like to give reason why it happens. So you should understand. Okay, next we'll solve some problem based on tension. We have seen this example with a ceiling fan type. Just imagine there is some kind of weight which is been attached to the wall or something with the help of a string. There will be definitely mg, that is your gravitational this weight which is of the body, This is nothing but the weight of the body. Suppose mass is 5 kg. Then this will be, if you are taking 10 as gravitational, acceleration due to gravity as 10, then it will become 50. Okay, so that would be turning out to be 50. But there is always, why it doesn't fall off? There's always a tension which is applied across opposite direction. So we don't draw arrow as such, we'll just write like this. So there's a tension always. Now this is, suppose if a single body is there, or a single string. Now look at this case. Which all possible tensions are there? We'll see for this one. Now there are two strings. So one, definitely the weight will be there. That is mg. Now two strings, it will always, remember, go away from the body. Why? This is trying to pull it down. But what is happening? The string is trying to pull it towards him. This string is always trying to pull him towards that other one. So tensions are always going away from the body. You name it as T1 and T2. In that case, it has two tensions, one in this direction, one in this. Suppose if it has many strings, those many will be there. So then in that case, it will be T1, T2, T3. The number of strings, those many number of tensions. Then its own weight is always there. It's nothing but the opposite force, okay, which is applied on the body so that the body doesn't fall. It tries to hold a body in rest position as it is. Let us see in this case, there are two bodies. This is M1, suppose this is M2, different mass. This one has M1G, this one has M2. Consider this is T1. Now, every string will try to go away. Now, this is going this side, suppose, for M1. If I'm mentioning it as T2. This is for this body we try. Now, for this body, what will happen? There's another force which will be coming from this side. Suppose this considers to be T3. Now, this body is trying to pull it this side, this body is trying to pull it this side. Same way, this will be T4. What is the relation between T2 and T3? Can anyone tell me? Will they be different? M1 length is not changing at all, that much only. So this body is trying to pull this side, this body is trying to pull this side. So what will be the tension? What is the relation between T2 and T3? Are they different? Are they same? What it will be? Will it be equal?
equal.
Yes, definitely, because it's the same string, no? So this, it's like a balanced force. So this one is trying to pull it himself, one is trying to pull in this side. So your E2 will be equal to T3. So whenever like this two bodies are there, you can just take it as normal T, because for both it will be same. Whether you take it in this direction or whether in the other side direction, doesn't matter, because in between them it's set. For this body, it will be this direction. For this body, it will be this direction. But value will always remain same. So if 5 Newton is applied this side also will be 5 Newton. Now simplest first case, calculate T. Everywhere we are going to calculate T, okay? Tension. Tension is nothing but the main one which is attached to the fixed. To calculate, we have to calculate this. So we know that always there's a force which is acting upon it, which is M. What is relation between T and mg? I told you. The body is not falling, the body is at rest. So when is it possible? What is the relation between this and this?
Opposite force is equal to tension.
Yes. They will always be equal, no? That is why the body is not coming to the ground. Why? Because whatever weight it is trying to pull down, that much tension is been created up. That's why it is balanced and he will always remain as it is at the rest. So tension we want to calculate. This is like you can consider when there is only one body like this, always your tension is always equals to your weight which is pulling down. These forces are opposite and equal to each other, equal magnitude. That's why it's like balanced force here. I told you this is a balanced force always. So tension, we can directly calculate what is this. Mass is 8. If you are considering this gravity to be taken as 10, then you can take 10. But if you are taking it as, what is that, 9.8, you can take it as 9 point. So in that case, straight away into 10, suppose we are taking just for simplicity, it will be 80. So tension will be 80 Newton. Tension is nothing but a force. So it's basically denoted in terms of Newton. Any doubt in this first, you can ask. Okay, next one. Calculate the tension for this. So what we'll do is, for this particular body we will take. Suppose if this is at rest. So as per that, what is the logic? We'll modify, we'll do the proper diagram again. with the arrows, otherwise you will not know what was the question, what we did. So this is 2 kg, this is 5 kg. Now we are considering this body. Now as per that, what is the logic? Tension is always on the opposite direction. It will never come towards this body or with reference to this. Suppose if you are calculating with reference to this, then it would be, for this fellow, it would be coming this side and then this side. Now with reference to this body. Anyways, this one is having is always last. There will be a weight acting upon. So we can consider this as T1 with reference to this body we are calculating. We can consider it to be M1 to M. Now for M1, what will be the balancing equation for this one? What are the, which all forces are acting? How many forces are there indirectly? Just see, this is there, this is there, this is also there. The gravity is also acting on it. It's like, and one more. Total forces are acting. Okay, so this also is pulling it, this also is pulling it, and this fellow is pulling up. So for M1, what is happening? Opposite direction. So T will always be equals to this plus this. You can consider as T1. See, there are two forces which are acting on this body. Suppose this was 10 newtons acting on this, and this was suppose 20. Then it's like 10 and 20 is trying to pull it down. So upwards had to be how much? 10 plus 20, that is 30, because this balance force has to balance these two. Then only it will remain at rest. Otherwise it will come down. So basically, as per the equation, what it will be, this upward force should be equal to your total downward force acting on that body. So this mg will be how much? You can calculate 5 into 10 we can take, that is 50. And what will be this one's own weight? So this T1 is nothing but this one's mg, because gravity is acting on this fellow also. Okay, if you don't want to get confused, we'll put it as m2. So total, this will be how much? 2 into 10, it will be 20. Total will be 20 and this will be 50. So there are two weights, that is this as well as this. So T will be total 70 Newton. Always the tension here is what? Gravity is acting upon it, so it is trying to pull it down. How much it is? 2. 2 into 10 will give me 20. For this one it is how much? 5 into 10, that will give me 50. So total how much is acting downwards? 20 Newton and 50 Newton. How much I have to need to balance? 20 plus 50, that is 70. So your main tension is 70 Newton. Anyone who has not understood? I'll stop here. The next class I'll continue with more problems.